So yeah. So yeah. So I have discussed about the Amazon warehouse. So in Amazon warehouse, similar kind of multi-robot systems are being deployed, and Dr. Chayan and Marichi and some other members of the team have been working in multi-robot systems, and also they are been trying to design algorithms for offline and online uh, task scheduling uh, activities, taking into account the current state of the arts and trying to improve them. So all these things are actually been done in Python. So they have been they have been designing and developing this kind of uh, uh, task scheduling algorithms. The prototypes have been designed in Python and have been tested in real time. So they have got 5, 6 patents on multi-robot task allocation, scheduling, and this kind of similar activities, which have been already filed in different geographies such as Europe, US, and India, and maybe in Japan too. So yeah, so the current state of the art in robotics in warehouses. So in this case, we have some robots that can pick and place objects, but in some cases there are the things that when a robot is deployed in such a warehouse, the uh, current capabilities of the robot are such that it is not uh, efficient in handling objects in a granular level. So the objects are actually carried from one point to another by actually the rack where the objects are been kept. The entire rack is actually carried from one point to another. So whenever there is a need for an object in a rack, suppose a rack X, so the entire rack X is been uh, carried from point A to point B. But here the main concern is that why should we carry the entire rack if we have the capability of carrying only one object from the rack? But there are many challenges in this thing. So the current robots, for example, the Kiva types of robots that are being deployed in the warehouses, so they actually carry the racks from one point to another, and only that object is been taken from the rack which is required. But the entire rack is being carried from one point to another. So researchers are actually trying to devise robots so that they can identify objects in a rack and carry only those objects which are required for them to be carried and not the entire rack. So this is one of the challenges in the current scenario in warehouse robotics. And also in this case, if a robot is to carry more than one object, that is multiple objects are to be carried from one point to another, then in that case, if the robot carries the entire rack, that it has the capability to carry the entire rack and not the objects in the granular level, then there will be an issue. It will not be able to carry all the objects from the different points. So this kind of disadvantages are to be taken care of in future. And for those, we need to have robots which have machine vision or computer vision related capabilities which can identify the objects in hand and then pick only those objects which are required, and then they can carry them from one point to another. So this is one thing. Okay.
Rishabh,
Yeah. Hello.
my audio is better now. Is it audible?
Yeah, it is better. I think it is better. Partho can comment on this, I think.
Yeah, I think whatever you said, Chan, it was clearly audible.
Yeah. I think
Okay.
Dr. Chan can continue now. His audio is clear. Yeah.
Rishabh,
Yeah.
you just change the slide. I'll try to.
Okay, sure. Which slide do you want to go to?
Just stay here.
Okay, fine.
So you can mute your mic.
Yeah, sure.
Yeah.
Sure.
So So why I'm trying to do this, because Rishabh knows the thing roughly, but he may not have the very finer details. So here, as Rishabh was saying, so the robots cannot pick, that technology is not mature enough that robots cannot pick individual objects from the rack. The objects can have different types of shape and texture. So there is a chips packet, there is a shampoo bottle, there is a glass object. So these different objects has to be picked or has to be handled in a different way. And robotic arms are not so the technology behind object manipulation is not mature enough to handle individual objects. So Amazon throws up this Amazon pickup challenge, and the idea was to how you can design a robotic arm which can pick individual objects very efficiently and accurately, things like that. So this is one of our robot, the arm. So we bought the parts of the arms and then we assembled, and then we wrote, basically we wrote the algorithm behind the manipulation. So this is in our daily lab. uh, uh, Rishabh, can you play the video? Is the video is playable? No, it won't. Okay, leave it. So happened is, in this case, the
Hello,
robot
Chayan.
actually, yeah.
Chayan? Yeah, I think I have the video separately. If you want, I can run it from a folder.
Yeah, that's better, I guess.
Yeah, that's better. You just show this video.
Okay, sure.
Then people will get the feeling that how it is working.
Sure. Can you see the screen?
Not yet.
Yeah, now?
Rishabh, probably you shared only the presentation. That's why the other portion is not coming.
So you share the entire screen.
Now?
It's coming.
Okay. So I'm running it from the start.
Yes.
Okay.
Yeah, you can see the robot is going and picking individual objects. So assume this is one of those racks that are stored in a warehouse. So the robotic arm can identify what kind of object it is and how to handle this kind of object. This one had a suction kind of gripper. Yeah. So next slide, please. This is, I think people got the idea. Rishabh? Hello? Rishabh? Yeah, coming. Yeah, next slide. Yeah, so we participated in 2016 and 2017 challenge. So in 2016, if you can read these smaller prints, so on fifth position you can see IITK and TCS. So it was a joint team between IIT Kanpur and TCS. So this was day one, the leaderboard. But at the end, we could not do that great in 2016. And at the end, Delft owned the challenge. So I graduated from Delft in Netherlands. So yeah, something to be proud of. In 2016, our team did not do that good, but in 2017 we did quite well. Though we were not the top team, but we there are different parts of the challenge. So in one challenge we were in 5th position and then 3rd position. So that was the thing. So if you see that the final the score, IIT Kanpur TCS team, on the right side, the top team, so that was on the 4th position, and we see we're much better than MIT Princeton team. So something to be really proud of, right? Yeah. So yeah, next slide please. So now imagine the scenario: you have robots which can go and pick individual objects, right? Now when this become mature and these are deployed in a actual warehouse, the scenario is slightly different than previous thing. In previous thing, what was happening, the robot goes, bring the entire rack to the human worker, so that human worker can pick that object, put the addressing stamp and ship it, right? And then go for the next object. So in this case, the tasks are basically the object, the location of the object and the object. So if there are 2 tasks, that means 2 different objects has to be picked up. So in the first round, the robot goes for the task 1, let's say following the blue line, and then comes back to the origin where the human worker is there. For the next task, it again goes and then comes back to the origin, right? But now the robot can pick individual objects. So in one round, it can pick multiple objects. So it can go to task 1 location, pick the individual object, then go to the next location, the next task location, task 2, and then pick that object and then come back to the origin. Or it may pick multiple more of them. So it really depends what is the capacity of the robot. Let's say the capacity of the robot is 100 kilo. It can carry up to 100 kilo. So all the objects it is carrying in one round should not cross 100 kilo. So it can carry many objects. So now the weight of the objects also vary. Different because in a warehouse you have a large variety of objects. So it's not very straightforward that I always pick 10 of them or 5 of them, because it really depends on what is the actual object weight. So now it comes it is a different kind of scenario where you can do this, but this poses a challenge in terms of task allocation. What is task allocation? You have a bunch of tasks and you have a number of robots. So you have to assign the task to the robots so that all the tasks can be completed in a minimal cost. In this case, the cost can be minimal time, right? So now you have a scenario where you can club the tasks together, but which way you should club, right? So if you do it carefully, then things would be better. If you don't do it carefully, obviously your task completion, all the task completion time would be much longer. So you have to design an algorithm. Next slide, please. Yeah, next. Yeah, so this problem can be mapped to a classical computer science problem called capacity constraint vehicle routing problem, or CVRP. And the problem is NP hard. In most of the real life problems are NP hard. People who don't know about the concept of NP hard, I don't know the background of the students. Computer science people would know, and people who have studied algorithm would know what is NP hard. But let me just give you a brief idea. NP hard is you cannot solve the problem optimally, or you cannot guarantee that the solution that you are finding is the best in a reasonable amount of time. So you can find a solution, but that's not the best solution. You cannot guarantee that. So those problems are hard problems. And so non-polynomial time, if you find a polynomial time algorithm, that is a algorithm which runs in polynomial time, and able to give you the best solution, those are relatively easier problems. But if you cannot do that, then those falls into NP hard. region, right? CVRP is one of the hard problems. Now, as I said, CVRP is a classical problem. So people are studying it for many years. People have studied it for, let's say, 50 years. But what people have studied, where the number of nodes, so number of nodes means number of tasks. So this problem can be represented in a graph format, right? So the task locations are the nodes, and origin is also the node, and the paths are the edges between the graphs, right? So the problem people have dealt in real life, where the number of nodes are relatively less, up to 100 or 200, because the practical problems are there. People have solved this problem for postal delivery or pickup scheduling and this kind of thing, right? Where number of nodes are relatively less and the number of vehicles are also less. But here we are dealing with a problem where the number of tasks and number of nodes are very large. It can be thousands. You can imagine how many orders are being received in a warehouse within a certain time frame, right? So we have to deal with a problem which is much larger in terms of input size, right? As I said, no optimal algorithm is possible. It's a NP-hard problem. So we have to resort to an heuristic algorithm, a suboptimal solution, but that can be good enough for this large scale problem. So we need a scalable solution. Next slide, please. So we developed the algorithm. I'm not going into the details of the algorithm. If you are interested, you can read the paper. The paper is mentioned at the bottom. So we developed the scalable algorithm. It's a heuristic algorithm, and we compared it with a so the OR tool. It's a Google optimization toolbox. It's a free toolbox. You can use it for any optimization problem, for solving any optimization problem. So we compared it with Google OR tools. The red bars are the OR tool solution and blue bars are our solution. So the y-axis is the cost. So the lesser the cost, the better the solution is. So if you see, when the so n is the number of nodes, so number of tasks, and k is the number of robots. When you see that the number of tasks and number of robots are relatively small, we are at par with Google OR tool. But when the number of tasks are more, we are doing much better than the OR tool, and that is where exactly we are targeting. That is where the application area is. Next slide, please. I think we have the video. So how this algorithm actually works. Rishabh, do you have this video? I guess you have. Can you play the video separately?
Let me check. Can you see my screen?
Yeah, this is.
This
is MPS video, I think. Can you check the NCAR video, NCAR demo?
Okay.
It's a separate one. Similar thing, but the visualization is a different one. So I will not be able to explain or connect it with that one. Could you find it?
Partho sir, it's Rajdeep.
Yeah, I can.
Sir, meanwhile, we can send a link to students for attendance actually. So it will take only 1 minute.
Sure.
That's okay. You can, sir. What you can do is you can just see the participant list and just note down.
Okay.
There's no separate attendance session is required.
Okay, fine. Thank you.
Hello, Chanda.
Yeah, you don't
Yeah,
have it?
I don't think I have the NCAR video. I have the TICAR and the MPS. Oh yeah,
Okay,
I have.
okay.
I got one. Yeah, I think this one is the one you were talking about. Let
Yeah,
me
yeah.
run it once. Is it the one?
Yes.
Okay.
Yeah. Go at the front and just pause it.
Yeah, done.
Yeah, you can just keep it there. Okay, fine.
Yeah,
So
sure.
here it's a mock-up of a warehouse scenario. So these rectangles are the different racks, and the gray bubbles are the task locations, right? So these are two separate things. Our solution is on the left, and right hand side is OR tool based solution. Here we have 4 robots marked in 4 different colors. All of them are currently at the packaging dock. So the idea is the robots are going to get a number of tasks, a number of objects, and comes back to the packaging dock, leave it there, and then goes for the next round. So can you play now? So there are 100 tasks in both in this warehouse scenario, and 4 robots. So one robot is assigned multiple tasks. As you see, it is marked with the color. So the green one is assigned with these green tasks. Pink one is assigned these pink tasks. Only because the robots can pick individual objects, so they can go and pick multiple objects in one round. So they all are returning back to the packaging dock and then leaving that objects and then going back for next round. So that way they are doing it. So what you will see at the end, that our algorithm is faster in terms of total distance, and that is the cost metric, right? So yeah, towards the end, yeah, the total distance for all the robot in our case is 2031. The other one is still running, and you can see it is more than that, right? Yeah. And yeah, next slide, Rishabh. So so far I have talked about these practical use cases and all these things. I haven't talked about much on Python, right? But this session is mainly for Python. Next slide, please. So the why I'm showing all this is basically to give you the idea that all the thing that we have done is using Python. So the algorithm design and code writing, that is using Python. The plot generation, so you saw this plot previously, that is using Python. This demo creation, this visualization, this video, that is also using Python, right? So you can do all sort of things using Python. Probably most of you already know this. Next slide. So I don't know how many of you have already used Python or not, what other programming languages do you know? But this is just a some opinion poll conducted by IEEE, and according to this poll, Python is #1 in terms of popularity, usefulness, and all these things. There are, one is for web, one is for mobile, one is for PC, one is for embedded device. So in all 4 out of these 4 categories, Python is not good or suitable for mobile devices. People usually don't do things using Python for mobile devices, but for other 3, Python is mostly used. You can see that C as a programming language, it is still quite popular. It's in the 3rd spot. Anyway, next. So if you think that you know Python, because as I said earlier, I'm not going to, it's not possible to tell you everything in this session, and not even in very deep in depth thing. What I will try to do is give you an overview. So if you are already familiar with the programming language with Python, so probably you will not be surprised, or you will not be learn many new things. But still, if you want to explore further things, because at the end I'll give you certain things, some generic aspects of Python and project management, that would be useful. Next slide, please. Just a brief history. Python started in 1980s by Guido van der Zoom at CWI in Netherlands, and since then it's picking up. The Google embraced it with open arms. So their search engine was mostly powered by Python, so that's why they got some early advantages. CWI here, if it is a face-to-face session, here is my turn to ask you a question, but I'll ask it anyway. Does anybody know about CWI or why it is famous for? There is another, so obviously Python is from this institute, but it is famous for another person, and that is a very famous computer scientist, Dijkstra. So probably you know the shortest path algorithm, Dijkstra's shortest path algorithm. So he worked in CWI in 1960s. When he was working there, he started working there as a computer programmer. That time there was those punch hole kind of programming things were there. So he was working there as a programmer. So that time, when you want to be married, you have to tell your profession to the priest. So when Dijkstra was getting married, the priest asked, "What is your profession?" And he said, "Computer programming." Then he said, "What is that? Is there any job like that?" Then he could not explain. So at the end, he said that I'm a physicist, and with that he said that he does a respectable job, and finally he got married. Anyway, so Python started from that institute. Next slide, please. Just to give you a brief comparison, or I think most people know C as a programming language, so it will be easier to just give you a heads up comparison to see how Python works, right? So this is the start problem, the first problem that people do, the hello world problem, right? So in C, if you want to write a hello world, you have to write that many lines of code on your left, and if in Python you just write one sentence. And C, you have to compile the code first to get the object code, and then you run the object code, right? So on the bottom side, in the terminal, you see first you compile the code, and then you run the executable. Python is a interpreted language, so you don't need to compile the code. You don't need to generate an executable. It just runs things line by line. So you just run the program with the Python command, and then it will run. Next slide. Yeah. So there is a start of every program. In C, you start with the keyword main, right? In Python, you can also mention what is the entry point of the program. You like this, that name equals main, so that the interpreter knows that this is the entry point. If you don't do that, if you just run write the instructions sentence after sentence, it will run sequentially. That's there. But it's a good programming practice. You explicitly mention the starting point of the program, right? So this is how you can do this. Next. Yeah, and then there is a programming block, right? So how do you define a block? If you want to do something, you have to write a number of instructions, and that constitutes a block. In C, defining a block is usually using the parenthesis. In Python, there is no concept of parenthesis, or it is not required. You use indentation, right? So you use one tab, and whatever is one tab down, that is part of the same code block, right? Next. And how do you do the console output? In C, it is printf. In Python, it is just print. So similar. Next. Comment. Another important thing, because often we write program for others to use, right? Even for myself, if I look at a program, and programs need not be only 4 or 5 lines, it can be 100 lines or more than that. So if I look at a program that I myself have written, after 1 month, I would not recognize immediately what is there. So a good way to explain the program is using comment, right? So how do we put comment? In C, it is double backslash. In Python, it is hash. So this is a single line comment. But if you want to use multi-line comment, there is hash star in C, and in Python there are 3 quotes. So you can look it up in Google, okay, how to do a multi-line comment in Python, right? Next. And library. Of course, we are not going to write each and everything from scratch. So we can, some people have written some function, they have implemented something, and then they provide it as a library. We can just refer to that library and call that function and get the desired output with the input. So in this case, math.h is the library function which has a bunch of functions. For example, finding ceiling or floor of a floating point number, or find cosine or sine or tangent of a angle, right? So all these things you can do using this library. In Python, similar library is available, and you call it math. In Python, you use import to use that library. And here I have used this math.ceiling in Python, and in C it is just ceiling, right? Next slide. The important thing about any programming language is how the variables and data structures or what are the inbuilt variable format and data structures or data types are there that we can utilize, right? Next slide. So in Python, there are roughly 2 categories. One is immutable data type, another is mutable data type. Immutable data type is what it doesn't change over time. You cannot change its constituents. You can reassign the variable name with another value, but once it is assigned, you cannot change its constituents. It cannot grow dynamically. Whereas mutable data types, you can grow it dynamically. So in mutable data types, you have number, string, and tuples, right? Number is number, integer, float, all. In Python, it's just number. In C, you have integer type variable, you have floating point type variable, right? And in C, you have to explicitly mention what kind of variable you are going to use. So it's with that int number variable, something, right? In Python, you don't need to explicitly mention what kind of data type. Depending on what you are assigning to the variable, what kind of value you are assigning, it automatically manages that, right? So you have number variable, you have string, and then you have tuple. Tuple is a collection of integer as well as string. Now there are mutable data types where you have a where you can grow the elements dynamically. So three major things are list, dictionary, and sets. List is like an array in C. So you have a number of objects there in the list. You can add more number to the list. You can delete numbers to the list, and of course you can access whatever already there in the list. In C array, you cannot dynamically change the size of the array, right? At the beginning, you have to specifically mention what is the length of the array or how many elements are there in the array, and explicitly mention what type of array it is. It's an integer type array or character type array. So if it is an integer type array, all the elements are of type integer. So it cannot have a cross type of elements. But in Python, you can have variable, you can have different types of elements within a list. As you see, my list, it contains the first element is a character, then the second element is a number, the third element itself is a list. Sorry. And within that list, you have two more elements. So it can be any collection of any elements, right? Now there is another data type which is called dictionary. Dictionary is again similar to an array, but it's a key value pair. So there is always a key and a value is associated with the key. So in list, if you want to think it this way, in a list, the key is the list index. So, and the indexes are always sequential starting from 0. So if you want to access the first element, you have to use my list 0 or my list 1 or my list 2, right? That way you can access the elements. In dictionary, you can access the elements through the key, and the keys need not be sequential, and a value of the key can be anything. It can be integer, it can be character, but the point is the keys need to be unique. There cannot be two keys with the same value. So I cannot have, here I have one key as 2 and the value is C. I cannot have another key value pair with 2 as the key, but I can have a key as 3, the value can be C again, right? Similarly, dictionary, it's again a collection, more similar to list, but the difference with list is that all the elements are unique. In a list, you can have elements that are not unique. You can have first element and second element identical. In set, you cannot have elements as identical elements. It's like mathematical set, right? So depending, you see, probably you can intuitively think what are the possible usage of different data types. Depending on your application and requirement, you can use any of these data types. Next slide. Yeah, Python is a procedural language. What is a procedural language? You define a function. A function means it is going to do an operation, right? It's like a mathematical function. You give an input, it does some operation, and then it gives an output, right? So in this case, the operation can be simple to complex, that is there, but you can define function, and then you can utilize those functions. C is a procedural language. Go next. So here is a simple example how we can define a function. So on the right hand side, this is the generic structure of a Python function. So how do you define a the Rishabh, just hold. Yeah, or you can just go next. It's okay. Yeah, just hold now. So so you can define a function using this format. You have to use this keyword def, and then you define your function name. You use your function name. So it's up to you whatever function name you want to use, and then you decide, you mention a bunch of parameters for the function, the input values for the function. Now in C, you have to explicitly mention the types of these parameters. Here you don't need to. So you just mention the parameters. It can take 1, 2, 3, as many parameters as you want. And then you define the body of the function, that is some operation, addition, subtraction, any other mathematical operation, finding max, finding mean, whatever, and then you return a value. It's not always, it is not necessary that a function should return a value always, but sometimes it does. If it is, then you use this keyword return, and then you put the value what that needs to be returned, right? Now come back to the left side, taking this format. So I defined a function that can find a maximum value given a list. So I first define the function name. The function name is find max, right? And it takes one parameter, and that is a list. Then I do this for loop, which what it does, it goes through the numbers. Initially, I assume that the max value is the first value. The first element of the array is the or the list is the max value. Then then I go through all the numbers one after another using this for loop, and I see if the current max value is smaller than the current element of the array or the list. If that is the case, then that becomes the max value, and at the end I return the max value, right? So as I mentioned earlier, you have the main here I have mentioned the start of the program explicitly, that is through this main, and then I define a list, right? So this list contains a bunch of numbers, and then I call this function find max and passing this list, and at the end I get the max value, and then I print the max value, right? Next. Yeah, you see this max value is returned, and that is now assigned to a local variable here, and then that value is printed. Next. Yeah, I talked about keywords many times. Every programming language has keywords. So Python also has keywords. These keywords are special purpose words which means something to the interpreter or the compiler, right? In this case, it is interpreter because Python is a interpretable language, right? So these words have some predefined meaning, right? So there are 33 keywords in Python, and you see these predefined keywords are here. So for any variable name or function name, you can use anything as you want, but you should avoid these keywords because these keywords have special meaning. Next, Rishabh. Yeah. Now, Python is also a object-oriented programming language. Python procedural language, that is fine, but Python is also an object-oriented programming language. Next. So, what are the any other object-oriented programming language? So, C is a functional procedural language, strictly procedural language. It's not object-oriented programming language, but Java is an object-oriented programming language. C++ is also a object-oriented programming language, right? Next. and Python is both. Now, just brief overview what object-oriented programming is. Basically, there are 4 features, and those are really helpful features that defines a object-oriented programming, and that's why this thing is there. This may look complicated, but while in use, you will see these are how beneficial these features are. The first feature is abstraction, right? So abstraction means you hide all the finer details and you give some sort of summary or a very high level view, so that it's easier to handle things. So anyone who handles who implemented a complicated thing, then it hides under abstraction, just gives a high level view. Anybody can just use it without knowing the finer details. A good example is a mobile phone. We don't know how things work, or we did not know how things works internally, but we can operate just knowing these buttons, right? So that's the good abstraction. Next, encapsulation. So when you do when you write large project, right, so you have some input data, and that data has to be passed through different function, right? You have to do different operation with the data, right? So the data can change if you do some operation on the data, and as the data change, data is stored within the memory location, right? So if one function can change the data, the value of a variable, and then another function trying to access the data, and then it sees that the value is something different, right? And different kinds of conflict can arise. To avoid that, encapsulation is the concept that is introduced. So it hides the data or the variables in certain way, so that unauthorized access is prohibited. You can do certain operation, but you cannot directly modify the memory location. So that gives you that cushion, right? Accidental memory modification can be avoided. Next, inheritance. Inheritance is it gives you a layered or hierarchical structure. So certain things are common between many objects, and if that part is common, you can have those certain common features and functionalities. So you need not implement all the features from the scratch. For example, cars, cycle, boat, all can be categorized as vehicle. If they are vehicle, then certain common feature can be specified for vehicle, and all the objects that are vehicle can have those features inherited. Now again, another thing is wheeled vehicle. So cycle and car are wheeled vehicle, so the features applied for wheeled vehicle is applied for both of these kind of vehicles, but not applied to a boat. So the cars and cycle can inherit all the features of a wheeled vehicle. Now again, between the cars, there can be different make of cars, right? So different company produce cars with different features, but the common features are there. All four-wheeled cars have 4 wheels, a steering, certain doors, right? So those are common features. So you can inherit those features from the parent, and then the further details you can add, right? So that gives you a that need not require you reinvent the wheel, right? Next, polymorphism. Polymorphism is another thing, is where you want to do certain operations with different types of input, right? So you want to do multiplication between two integers, you want to do multiplication between two numbers, or here you multiply, you just want to repeat the string multiple times. So here you just mention, you just use same function name but different types of parameter, and polymorphism is the feature which gives you that flexibility, that as a user I don't need to recall the usage of the function, I just need to recall the name of the function and know sorry, I need to recall the usage of the function, I don't need to recall what input format it is explicitly required. So I can be very flexible in this way. Okay, so I can give input in different ways and still it gives me the desired output, right? Next, so these are the 4 features that Python has, and rather any object oriented programming language should have, and Python also has that. So it is both a procedural and object oriented programming language. Why both? It seems that object oriented programming is the best, it is always better to use this. Apparently it is not, there are many restrictions and many difficulties. So in times you can use just procedural thing. So that's why Python has the flexibility and you can use it for in both the mode. Rishabh, I think this is a video. Do you have the video? This demo. Do
Hello?
you have
Yeah,
this?
yeah. Let me check. Yeah.
Yeah. Yeah, this is bit odd. Sorry for the technical difficulties. That's one thing, but this is a bit odd. It feels like I'm talking to my iPad and there is no one listening.
Hello,
Rishabh,
Chanda. Yeah.
yeah, if you,
Do you remember the name of the video?
not exactly. Leave it. That's okay.
Okay.
It's not that important. Just
Okay.
go next.
Okay.
So this one was just a animation, similar kind of animation you have seen earlier as well. It is just an animation, and I was trying to point out how this animation was created using Python. So just go next. Yeah. So this program is written in an object-oriented structure. So you define your class and then use that class. So the main program is just this. It is as small as this, and the basic features are written in another class file. And of course, I am using a bunch of libraries as well. So next, Rishabh. Yeah. So what it does is, first I create an object of a class. So I defined the class as the name of the class is animated execution, right? And this class is defined, or the program for this class is written in a file called simple underscore animation. So at the top of this file, I imported that class. So from the file name, I import this class. In the same file, I could have explained multiple class as well. So and in this program, I need not import all the class. So I can explicitly import a particular class. In this case, this animated execution, right? Yeah, next. Yeah. So I am importing the class. So this class and this, when I create an object of this class, I inherit the properties of this class. I can do operation using this object. So the object is this sim and env, that is simulation environment, right? And then what I do is go next. Yeah, then what I do is I call a bunch of function defined for this class. So the first function is add robot. So within a for loop, the loop runs for 5 times. So I add 5 robot in the simulation environment, and then I do the animation. So animation show. This is a function which shows the animation, right? So this is this was actually, just imagine that you have seen the video. It's on the line of that warehouse thing that I showed earlier. It just adds up different robots, and then the robots move randomly. That was the video. Next, please. Now, what I did in the class 5, right? So the point is, you define a class to provide to pack a bunch of features, to pack a bunch of functions together, right? So that to define a class, you use this keyword class and then your class name, and then you define the functions. So there are there can be any function that you can define. There is one starting function or the constructor, so-called constructor of the function. That is, whenever you create an object of the class, this function will be called automatically. And in this case, the constructor function has a special name called init, _init . So that is the constructor function. So when I'm calling the function, when I'm creating the object, this function is called. And this function takes 2 parameters. Rishabh, can you click next, see what is there? Yeah. So the class name are there. Next. Yeah, constructor overriding. Next. Yeah, go back. Yes. So here I'm calling this function. Now you see this function takes 2 arguments: field width, field depth. There is another one self. For the time being, just ignore that. Okay. So this one takes 2 parameters: field width and field depth. So that one is basically to define how big the area would be where the robot will be roaming. But when I'm calling the when I'm creating the object, that is when I'm calling the class, I'm just passing one variable. See, field depth on your left. How is that possible? Because of polymorphism, right? So here you can have variables that are default. When you define a function and you define the input parameters, if you attach a value with the default value with the parameters, then it becomes an optional variable. So here, when you see that this init function has these 2 parameters, field width and field depth, both have some default value, 30 and 30. So that means both are optional. So you could have called the class without passing any parameters. In that case, both would take 30, 30 as the default value. You can call the function or you can initiate the class with only 1 parameters, either of them or both of them. In this case, I am calling it with only 1 variable, that is field depth. On your left, line 8, field depth equal to 20. So in this case, I am mentioning the value as 20 for this parameter field depth. So in this case, the field depth will have the value 20, but the field width will have the default value 30. Next. So the other functions, here are some functions. You can define as many functions as you want. So like I showed earlier, you define a function like this using the def keyword, then the function name, then the parameters. Now this self variable. This self variable is basically saying that there are some global thing for this class, and you access those global things through this self keyword. So this self keyword is there with every function. The other things are the actual parameters, passable parameters. So when you call the function, you not use self, it is there by default. And this self is used to access any variable or any function of this class, right? A function can call another function, or a function can use another variable of this class, right? Rishabh, go next. Yeah, public method and private method. Now there are two kinds of method, public and private. Public methods are those that can be called from outside the class. So outside the class means where I have created an object of this class. So in the main program, I have created an object simulation environment, and I can call the public method. The public method is add robot, so I can call it. But the private method I cannot call from this main program. Okay, and how do I define which one is private and which one is public? The public one is just the name, function name without the underscore. When I start a function name with double underscore, that becomes a private method. So Python interpreted that way. So you see that method, private method, I call only within the class. This add robot method is already defined within the class, so it can call this private method, but it cannot be called from the main program, right? Next. Yeah, so now another important aspect that I want to touch upon is call by value and call by reference. In C, most of the time when we pass a parameters, we pass parameters to the function, it is called by value. Okay, that means when I pass a parameter, I just pass the value, and within that function, in the memory space, it created a local copy of that variable and then put that value there. So the original copy remains intact. But call by reference means you pass the address. So whatever change you make, it actually reflects at the same location because it's the same memory location. It doesn't create a separate memory location. So in this case, in Python, so let's look at this example. Here, what I'm doing is I have a function called scalar multiplication. What it does is given a list and a factor value, all the elements of the list are factored, are multiplied with that factor, right? So the list is defined here in the main part, and then I call this function. If it is a call by value, all the multiplication would have done, the memory location would have been a different one. So when I print it here in the main, there would not be any impact. So after the multiplication, the values would be 120, 70, 100, 10, and so on. But that would have been limited within the scope of the scalar multiplication function. But since this is a call by reference, it's the data or the data list, it's the same memory location. It shares the same memory location. So whatever changes happened, it will reflect here. So if you print this, if you execute this, the print statement would print 120 instead of 12. Rishabh, next. Yeah, here was my chance to ask you a question, but that is not possible. Anyway, next. So that is more or less about brief introduction about Python. there are certain concepts that you need to study. These are generic programming concept, and similarly and equally applicable for Python. While you study these things, you will understand the syntax of Python as well. So here is one book. This is sort of a good book. There are a lot of tutorial and resources available on the internet. This is just an example. Rishabh, next. Yeah. Now, the good thing about Python is you have package or you have library for almost anything. So you don't need to write very extensive code, or you don't need to write code from scratch for almost everything. You just install a set of packages, call the functions, stitch things together. You have to just do the orchestration, and then your program is ready in many things, for many things, right? So how do you get the packages? So pip is the package manager. So you use this function pip install and the package name. You need to know, of course you need to know what package I need, and then if you just do instruction, it will be installed, and then you just import the package and use the functions. Similarly for uninstalling, but if you have a large number of package requirement, you can put them in a text file sequentially, and then do this pip install this recursively, and it will install all the packages, right? Next, yes, NumPy. NumPy is one such package that you can use along with Python. This is a specially designed package for array or multi-dimensional number handling. Python already has a list, so you can create list of lists and list of lists. So that means that will give you the sort of feeling of a multi-dimensional array, right? But that's not exactly the thing. NumPy has certain benefits over typical Python list. First, I'll tell what is the limitations of NumPy array as compared to the list. Then I'll talk about the benefit. The limitation says Python for numbers. Okay, it cannot handle strings. In Python list, you can have numbers, you can have characters, you can have mix of both. In NumPy, you cannot have that. Okay, that is by design. So that is the only limitations. Otherwise, if you are dealing with only numbers and you have to do a lot of mathematical operations, linear algebra kind of thing, matrix operation, then NumPy is a very good tool. Next. I think you skipped one. Oh, okay. That slide was not there. So just yeah, go back. Yeah. So then I'll tell you the benefit. The benefit is basically how the memory is allocated for NumPy array and Python list. For Python list, the memory allocation need not be contiguous. For every, since the list can grow dynamically, also you can add elements to NumPy array, but in Python list, the things can grow at any time, and it can have different types of data type. So it's a collection. So it internally handles in which memory location the elements are stored, but in terms of memory, the allocation is not contiguous. Different elements can have at different memory location. But in NumPy array, all the elements are sequential, like a C array, right? So So mainly because of this and some other reason, the handling of NumPy array is much faster. So if you want to do any operation on a NumPy array as opposed to a Python list, the speed is much more. So if your program has lot of matrix kind of operation or multidimensional array handling, obviously if you are dealing with list, your execution time will be much higher, and if you are dealing with NumPy array, things will be much more faster. So that is first and foremost reason. Additionally, NumPy arrays have a lot of easy to use functionalities, and those are very handy functionalities. So that's easier to do many operations which are not there in Python list. Next, please. Yeah, so the takeaway from a major takeaway from Python is there are a lot of packages available, and it's easier to plug them together to build a project. Dependencies are sort of handled internally. You don't need to think much about that. You just do pip install and things will be there, and then you just have to plug and play. In other programming languages, that is not the case, and that's the major reason why Python is so popular. Next. Now, another thing, this is a generic aspect. This is not Python specific, but the generic thing, debugging, especially when you handle a very large amount of code base. So often we write code and there is some bug, and bug means there is some error or some issue with the program. So it is not behaving as expected. So obviously we have to fix that, right? And that requires a lot of practice and training. Things are not that easy at the beginning. This is not rocket science as well, but at the beginning debugging can be a lot of a very painful thing, but yeah, this is an essential process. Next. So there are basically three kinds of error that we deal: syntax error, runtime error, and semantic error. So syntax error is a programming language defines things in certain way and you are not following that properly. So that is the syntax error, and that is relatively easier thing, because most compiler or the interpreter actually can handle this. They give you error when you try to run the program. So with that you have the clue that okay, I did the mistake of syntax error, so you rectify this and things will be fine. So when you start a programming language at the beginning, this thing will happen a lot more, but with practice this thing will be less and less, and these things are easier to handle. Runtime error is something that happens runtime which you cannot see at the beginning, and those thing is because you wrote the logic in certain way. For example, you did division by 0, which will obviously will be infinite, but at the writing time you don't see that error because it's not a syntax error, right? You wrote the program syntactically correct way, but when you run it, because of that kind of thing, you run into runtime. So these things can also be handled easily. The most notorious and the difficult one is the semantic error, right? So that comes with the logic of your algorithm, right? So programming, so you know that you want to implement this functionality, this feature, so things will be done this way, this way, this way, and with that logic there is certain flaw. So if that is the case, your output will be different. So there will not be any issue with running the program. You run the program, it runs, it executes, it executes and it gives you the output. But the output is completely different as you expect. And why is so? Because of the semantic error. Because the logic that you implemented is incorrect as opposed to what it should be. So now you have to figure out why is that and where I am making the mistake. So that would be the difficult kind of error to handle. Next, please. Yeah. Some suggestion about best programming practice. These are not exhaustive list. Rishabh, next. But these are, I think, from these I try to list down from experience. You try to use the good programming practice from the beginning. At the beginning, we have the tendency to just get away with it and just get the output. But at the end, it will be very difficult to manage it as the project grows bigger, or later you want to see the program again, or you want to pass the program to somebody else. So in Python, it is like use consistent indentation. As I mentioned, the code blocks are defined using indentation. So this is syntax error that you will anyway identify with practice. Second thing is do not repeat yourself. That is, whenever you want to have a certain feature multiple times, you just define a function for that. You don't repeat that multiple times. Write a function. Whenever you want to use it, just call the function, right? So that's easier. Similarly, avoid deep nesting. So whenever you want to go deeper and deeper, you can again define a function for sub-nested part and then use a upper layer nesting. Limit line length. Obviously, you can do a lot of operation within a single line, but if you do a lot of things in a single line, it lose the readability. So anybody who tries to read it would face a difficulty to interpret how or what is happening. So if you want to do one addition, one multiplication, simple example, one addition, one multiplication, one inverse, and all this thing, you can do it in every line with a comment probably, and that this line I'm doing this operation, or this line I'm doing this operation, then it becomes very readable. Next. Yeah, file and folder structure. So you need not write every class, every function within a same file. As I showed earlier with example, you can use different files to write different set of functionalities, different set of class, and that makes it easier to handle, right? You wrote one function and you tested that function independently. Now you know that this function works as expected, so you don't need to touch, and you store it in a separate file. You don't need to touch this file anyway. Next, whenever you want to use that function, you just import that file, import that function, and then call it. You don't need to touch that file at all. So that gives you a very nice way or easier way to manage programs. And later you can also pass this class or pass this file to anybody, saying that this has these things. If you do API description, so anybody can also use it without looking into what is there or changing it, right? So that is a good practice. Naming convention. Obviously, you should try to use the class name, variable names with a meaningful name. Don't use A or B as variable name, because later it would be difficult to understand what this variable is for, right? If you have a meaningful name, then immediately looking at it, people would understand, okay, this variable is for this, right? So try to use that way. Next. Yeah, again, functions should not be too long. It should not be too complicated. You can have nested function as well. So it should ideally it should do one single operation. So let's say you want to write a matrix multiplication. So you just write a function. Now you want to calculate matrix inverse. You know, to calculate matrix inverse, there is multiplication and many other things are involved. So so for all of this, you can write everything in one function. But instead of that, you can have a separate function for multiplication, separate function for rank calculation, and all this. And then within the inverse function, you just stitch them together. And then another function who wants to do matrix inverse, just call this function. That way, things will be simpler structured, right? Next. Yeah, this is another important thing is you should not hard code numbers. Even if you know that this for loop is going to run for 10 times only, still you should write a parameter, and that parameter value you assign that parameter value as 10, right? So that later, who knows, if you need to change something, you change it at one place and rest of the things remain as it is. So if you do hard coding, and if you want to change something, you have to go and figure out wherever I did this change, wherever I used it, I have to change in every place, and that's a difficult thing. Next. Yeah. So try to use object-oriented structure. Try to use class-based thing, especially when you are dealing with large project. So one set of functionality, put them within a class. Another set of functionality, put them within another class, and that way you can do it. But if you don't see a lot of clustered functionalities, you can just define multiple functions. You don't need to use class, but then put those functions in a separate file. Now for class, always try to use private and public clearly and mindfully, because as I mentioned, why there is private and public. Public is for whatever needs to be exposed to the outside of this class, and whatever need not be exposed, you should make them private, so that accidental use or accidental modification can be avoided. That is applicable for both variable and function. Variables you can also define as public and private similar way, with double underscore, right, and without double underscore. Yeah, you define APIs for class and expose it so that anybody can use it just knowing the APIs. They don't need to know the implementation details. They just need to know the API. That means they need to know, okay, this is the function name. This function does this. It requires this input variables, and it gives you output this. So that's it. I have to know. I don't need to know how this is actually achieved or how this is implemented. So anybody can use it, and even you can use it later. Use comments, of course, because whenever you are going to do collaboration or anybody is going to read it, even you are going to read it after 1 month, it's going to be tough. Next. Yes, version controlling. Again, things can change at the beginning. Things are not properly finalized, especially when you have a running project. At the beginning, you have one version, and then next you change something. Who knows, after changing thing, you face a problem. You could not figure out where is the error. So it's easier to go back to the earlier version where things were working, and then you again go and change things gradually to get the next change. So how can we do this? You do version controlling. So there are a lot of version controlling systems are there: GitLab, GitHub, SVN, all these things. Use any of this. Do not write your code in simple text editor. Try to use an IDE. That will give you a lot of feature. For example, it can easily give you a function name, for a class, what are the functions there for a class, what are the parameters it takes, so you don't need to go and look it up or remember everything. Then if you want to rename a variable, it can be easily renamed, and all these features, right? So and it can also show you syntax errors while you type. So all these features are there, so use an IDE instead of using a simple text editor. Yeah, always initialize variable. That is another thing. Next. Yeah, now I have talked about many things. Until and unless you do things in actually, you would not realize it, you would not see the things, you would not get the feeling. So you should do this. So what you should do is you try to define a project and then work on it. A simple example can be you form a group among yourselves. For example, the two or three friends, and then you write a program. Each of you write a program for different sorting algorithms. So one person write a sorting algorithms for bubble sort, one person for heap sort, one person for merge sort, and then you combine them to see which one is performing better. So among yourself, you should have the discussion that all the sorting algorithms should follow the same API. That is, they should have same set of input and same sort of output, and then so that you can easily merge and compare the results, right? So that kind of thing you can do. Next, Rishabh. Yeah, the same thing I said. You can also pick up some machine learning kind of project as well. People use Python, or people start using Python when they start learning machine learning, because a lot of machine learning libraries are available with Python, or the tools or softwares are there for machine learning, has very good Python interface, so it's easier. You can pick some of those projects as well. Yeah. Next, I think that's it. I think it's one-sided. So now is your chance to ask some questions.
No, Chan, Chan, we are not yet done. It's not just one-sided. So I can see some hand are raised. So they might have some questions.
Yeah, sure.
So once you are done, we'll answer.
Yeah, I'm done. So please start with the question answer.
Okay. Pradeep, you are able to do. I can see Anjali Omnar Ansari is having some questions.
Yeah. What is the difference between set variable and tuple variable? He is asking about that.
Yeah, so in tuple, you cannot add new element to a tuple. If you define a tuple with 3 elements, it remains as it is. If you really want to add another element, you cannot add it with the existing tuple, but you have to completely redefine the tuple. So for example, initially you have 1, 2, and 3 as the elements of a tuple. Now you want to add another element, which is 4. You cannot. So only way to do it is you just reassign the tuple with 1, 2, 3, 4. But in a set, you cannot reassign things. You have 1, 2, 3 as existing element. You just add another element. That is true for any of these dynamic things. List, set, dictionary. For all of this, you can have this dynamic addition.
And another question probably. No, the same question. Only one question.
There was a raised hand. I could see.
Okay.
Anyone has a question can raise hand so that we can identify and unmute. Or put your question in the question answer box.
Hanzala Umair. Hanzala Umair.
Yes, sir. Hello. Hello, sir. I was actually asking about one thing that you were telling about Python. So there are actually numerous number of libraries which we are not able to actually remember. So how can we use those particular libraries even if we don't remember the names of those libraries, sir?
Yeah, you do Google search. Google is there for your rescue. Google do not solve your problem. It gives you useful information, right? So it's a information aggregator. So you just you know what you are trying to do. So with that you just roughly formulate your query. You want to solve a certain kind of problem. So and there might be a library for that or a package for that. So you just search package for this kind of thing, and if there is anything, I'm sure Google will show it up. That's the only way.
Okay, sir.
Or there are different groups, online groups, where if you cannot find, you can ask this question,
Actually,
and then people can
sir, I
try
wanted to
answer.
ask something about related to numbers. Hello?
Right.
Oh.
Yeah, please go ahead.
Yeah.
Sir, related to numbers, sir, actually in while you were talking about that particular thing, integers, double, byte, short, int, long, something like that, those belong to number categories, right, sir? So
Right.
each and every time we write a number, sir, it actually takes up a certain amount of space, right, sir? If we are using, say, a byte, then it uses actually 8 bits, I think so. Yes, sir, it occupies 8
Yeah,
bits.
so
Actually, it can represent a particular number. So in Python, sir, how
yeah.
does it work?
So what is your question? Yeah. Okay. Yeah. So
sir,
in Python. Yeah. Please go ahead.
no, sir, I am complete. Yeah, I completed my question.
Okay. In Python, there is based on the value, it allocates the memory space. Okay. So there is no explicit thing. There is a good garbage collector in Python. So garbage collector is the memory location that are not used anymore. Those are already freed, automatically freed. In C, that is not the case. So that's why you have to do explicit typecasting. And the idea of typecasting is the compiler will allocate the memory accordingly. In Python, that is not required, because garbage collector can handle it. If you in future, if you are not utilizing it, it will automatically release that memory. So that's why you don't need to specify the type explicitly. Depending on the value, it allocates the memory. And that is the reason if you are dealing with numbers in a list, it's quite slow. It has certain benefits, but it is quite slow for operation. Whereas if you use NumPy, where you can use numbers, so in NumPy you have to mention the size explicitly. So if you mention the size explicitly, then accordingly it allocates the memory. So the memory management is much more tight, and since it is contiguous memory, the operations will be faster. So that is how basically Python handles it.
Okay, another question probably. Uh, some one more query, sir. It's a question from an attendee. Is Python also associated with solid case and Yagni principle along with dry principle? Hello.
John, you can open the question answer box.
Yeah,
There are a couple of questions waiting there.
okay.
But I could not understand why anonymous attendee. Is there a reason?
I don't have any idea, sir, regarding this.
Let's skip that and let's go to the next question.
Okay. So it's from Divyam Raj. Multiple inheritance is possible in Python. If yes, then how can we apply it?
Multiple inheritance, I think that is not possible. You can let me think. I haven't did that explicitly. Class inheritance, yeah, you can have a single superclass. You cannot have multiple superclass or multiple parent class. So I don't think it is possible.
Okay.
Though I'm not sure, very sure. You can just do a Google search a bit. Yeah.
Okay. Okay, fine. So no more question from students probably. And if anyone have any question, please write this Q&A box. No questions.
Or you can raise your hand so we can.
And you can, yes, you can unmute them.
You can raise your hand so we can unmute.
No questions.
Okay, then I think then.
Sir, one but not the least, I think I have a question,
Sure.
sir. If,
Sure.
if a particular student wants to start, with Python and all, what will be the suitable textbook or something like that from where he can learn? Means, if it is as it is a new. So, if anything, if you have any kind of guidance.
Yeah. So the one is typical Python doc, right? So that is the official documentation, but that's I would say that is a bit boring. So the W3C school, that website has Python tutorial. You can start with that. That has a, I would say, easy and quite flexible start, and student can follow quite easily, and it has practice along with the session. So W3C school, that has many tutorials. They also have Python tutorial, but that is one. And second thing is you can start look at this book. Rishabh, can you go back? I mentioned there are many books, but this one I found quite nice. So at one slide I have mentioned one book. I don't recall the slide number. Go back. Yeah, go back. Yeah. No. Oh, it was there somewhere, right, Rishabh? Next key after the keywords. I think there was a thing. Yeah, go next. It's top of my head. I don't recall the name of the book, but okay. what I'll do, I'll pass you the name, and then this. Learning Python, how to think like a computer scientist.
Okay.
And another thing I think many people might know, Python 3 is Python 3. There is many software has backward compatibility, that is whatever was there in previous version, in newer version you can always do that along with some additional things. That's not true for Python. So Python 2 you should not use, because it is stopped. It's dead now, so the support is stopped. So do whatever you do with Python 3.
Okay, sir. Ishita De has a question. Sir, can you give us some idea about Flask?
About what?
Flask. Flask.
Flask. Okay. I'm not sure what is Flask.
Okay. Probably another question.
Can you unmute Ishita?
Ishita is not raising his hand. So just hold on. Just hold on.
Oh, Flask is it says Flask is a micro web framework written in Python. Okay. So it's a Python based framework. Right. So yeah, the syntaxes will be like Python, but it has a certain purpose, right? So I think if you are referring to that, so that's it. I never used it. In fact, I just came to know about it right now. So yeah.
Parthu sir, I think it's all about. Nobody have any question right now. So
Okay.
Sir, actually,
So we can
questions
conclude the
because sir, it is a very new technology, and today's session is a nice sessions. I think it's a very nice sessions, and there will be, I think, student lesions from that, and they will be study. If they have any queries, sir, then they maybe send you mail and all. You send you already given your mail ID, sir.
Sure.
Yeah.
Anytime.
Yes.
Yeah, and thank you very much to everyone. Special thanks to Rishabh, and of course,
anytime.
All right.
Thank you.
All
thanks
right.
to
Thanks to
Rajdeep sir and
Chan.
Parthoda. Yeah.
thank you.
So I hope it is helpful, and because that's our objective. If things help you, then we are successful. So you are continuously in touch with your teacher. You speak to them. What is your requirement? What kind of session that can be organized by TCS to make sure that on the other side what is happening. Like theoretically you are learning, and then what is happening in the industry in the application side. We'll try to fulfill as much as possible. We also have a bandwidth problem. Because alone Eastern region is having more than 100 groups that we are regularly doing workshops and FDP sessions. So, but we will try to do our best. Thank you. So we'll conclude today's session.
Okay, fine.
Thank you.
Thank you so much.
Thank you.
Bye.